Okay, here we go. So this next unit is ions and ionic bonding. And we briefly talked about ions back in the electron configuration when we were studying electrons back before, way back in 2024. But now we need to go more into. So what I want you guys to do, first of all, is to get this main idea that all atoms try to look like noble gases. All right, and what we mean by that is by look like is to have means having the same electron configuration. All right, so the electron configuration of noble gases always finishes with noble gases they have an S2P6. They finish with 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6. So the 4S and the 4P would have the 2 and the 6. They always have this S2P6 configuration. Okay, and that means that they all have 8 valence electrons. Okay, and because they have these 8 valence electrons, this S2P6, okay, this is considered a stable. It is a stable electron configuration, meaning it doesn't want to change. It's not going to do anything to gain or lose electrons, which is what ions are. They are atoms that have gained or lost electrons, so that they do look like noble gases. All right, so this concept of all having 8 electrons and noble gases have an S2P6 configuration, and everyone wants to look like an electron, wants to look like a noble gas, is called the octet. The octet rule. All right, that all atoms try to fill their valence with 8 electrons. So let's take a look at all right, let's take a look at fluorine right here. Oh, don't need another color for that. Let's do look at fluorine. Okay, fluorine is atomic number what? Okay, fluorine is atomic number 9, right? What would the nearest noble gas be to fluorine? Okay, it would be neon, the one, right? Remember that these guys, right? Remember that these are, I want to fill. Okay, so fluorine, right? So these guys right here are the noble gases, okay, and they all have the S2P6, right, electron configuration. So fluorine right here, fluorine wants to look like neon, okay, but it doesn't. How many electrons does fluorine have before any changes? Okay, it should have 9 electrons, because everything we've taught you guys so far is that the electrons equals our number of protons, right? That's it. Okay, so this is the chapter, this is the unit that changes. All right, electrons aren't always the same as protons, and this is what happens when they do change, and this is why they change. Fluorine has 9 electrons, but in order to have a stable electron configuration, in order to obey the octet rule, it wants to look like neon. Neon has 10 electrons. Okay, or more to the point, fluorine. Oh, that needs to be. Shoot. Can you guys see that? The fluorine. Okay. Fluorine is going to have a right. It's going to have valence electrons, and it's going to have 1, 2, 3, 4, 5, 6, 7. This ringing a bell? 7 valence electrons. S2, P5. Yeah? Okay. But neon, like it's neon light. All right, neon. Neon is going to have all 8. How many electrons does fluorine need to look like neon? It needs 1 more electron, right? Okay. Well, if fluorine gets that 1 electron, okay, if fluorine gets that 1 electron, all of a sudden it now has 10 electrons, but it still only has 9 protons. They're not the same anymore. Okay. So there's one state of atoms where it's somewhat stable, where they have an electrically equal number of protons and electrons. Okay. Or we have this stable state that follows the octet rule, where it has 8 electrons regardless of how many protons it has. Okay. And now we have an imbalance of charge. We have more electrons than protons, and so the total of this, 9 protons minus 10 electrons equals 1 extra electron, right? So it's going to have a -1 charge to that fluorine. Okay, it has 1 extra electron, so it has a -1 charge. And so we write this as F minus. You guys follow me there? Okay, it has an extra electron. That electron has a negative charge, has a -1 charge. And so this ion, the fluorine ion, is a -1, F -1. Yeah? What do you think oxygen would be then? Right, here's oxygen. Oxygen needs 1, 2 to get to neon, right? Oxygen is going to have 8 protons, right? And so this is protons minus electrons. So it's 8 minus 10 equals a -2. So oxygen is going to be, it's going to have 2 negative charges on it. because it needed to gain 2 electrons. That makes sense? Okay. Then we have nitrogen. What do you think is going to happen with nitrogen? Okay. It's 3 spots away. So it's going to be a -3. Does that make sense? Yes. Sort of. Sort of. You're getting ahead of us. Okay. Well, cobalt and particular. So these guys down here, we're not going to talk about transition metals until probably Monday or Tuesday. Okay. All right. Or actually, in a little bit today. Your assignment today has a little bit about it. Okay. So now, by that idea, what happens? What if we were looking at calcium right here? Calcium is atomic number 20. By atomic number, what is the closest noble gas? There's argon right here, which is below 20, and there's krypton at 36, which is above 20. Argon is 18, krypton is 36. Which one is closest in valence electrons? Or, more to the point, if calcium wants to look like krypton, it needs to do what? We are 1, 2, right? Because the transition metals don't count. 1, 2, 3, 4, 5, 6 electrons away from looking like krypton. Yeah? How many electrons away are we from looking like argon? 1, 2. We go back 2. Yeah? What would that mean? Going back 2 spots would mean we're doing what with our electrons? Guys, Caleb's kind of leading us here, so I need you to. Okay. If we're going to go from 20 to 18, we're going to do the same thing. So calcium has 20 protons. And if we're trying to get to argon, what is 20 minus 18? Right? That's going to be, instead of being a negative or a negative, this is going to be a positive 2. Right? Okay. So calcium is a plus 2. Yeah? Because it lost 2 electrons to look like argon. All right. So what do you think? All right. So we've got everybody in this column right here. Everybody in this column is going to be in fact, let me do it like this. We've got that and that and so everybody in this column is going to make a -1 charge, yeah? And everybody in this column is going to make a -2 charge. And everybody in this column is going to make a -3 charge, right? Well, we found calcium. All of these guys are just 2 spots away from looking like a noble gas from the previous noble gas. So these are all going to make, that needs to be a +2, right? What do you think this first column is going to be? plus 1. That make sense? Okay. What do all of their valences look like, though? So here's what I want you guys to do. So I want you to draw and we're going to do calcium, potassium, argon, chlorine, sulfur, and phosphorus. Okay, and I'll give you a hint. That's what argon looks like. Okay, what are all of the other ones going to look like? What was the big rule that I told you guys at the beginning of the lecture? All atoms try to look like noble gases. So when these guys make ions, they're all going to have what? Sam, a little louder. Yeah. They're all going to have 8 valence electrons. Okay, for all of them. Okay. Calcium is going to lose its 2 electrons and revert back to the previous energy level. Okay, and look like argon. Potassium is going to lose its single S1 electron and revert back to the earlier energy level and look just like argon. And argon looks like argon. It doesn't want to change. Chlorine will gain an electron. Sulfur will gain 2 electrons. Phosphorus will gain 3 electrons. So calcium will be a +2, potassium will be +1, no charge, -1, -2, -3. Uh-huh.
How about carbon? Is it like this?
Good question. Carbon is 1, 2, 3, 4, equidistant from 1, 2, 3, 4, right? So actually it doesn't do either of them. And carbon has its own classification, its own bonding process, okay, that doesn't get included in ionic bonding, okay? And so it's the exception to the rule. Good question. You found that, the +3, -3s. Okay, but by that regard, here's carbon, doesn't count. What is aluminum going to do? +3, yeah. Does that make sense? Okay, so that is how we make charges on ions. Okay, we make charges on ions according to the octet rule. Okay, all of our atoms try to gain or lose electrons to look like noble gases. If you're already a noble gas, you're already a noble gas. You don't need to gain or lose electrons. Okay, but everyone else tries to get the 8 electrons on the outside, and then they have an electrostatic charge on them. Okay? All right, that's it for the lecture today.